All right, this is Daryl. So joining me is Justin, and we will be covering the VXLAN enhancements. What's new in 10.8 for VXLAN? So these 7 features are new in 10.8. We'll be covering each one of them. So GBP and Stub VTEP, they are related to VMBT for the campus VXLAN. We also add on DHCP relay over VXLAN for software parity to 2 new platforms, and ping traceroute over VXLAN for both V4 and V6 is supported in 10.8. Radius RadSec over VXLAN with V4 and V6 is also supported for certain platforms. Finally, IPv4 multicast VXLAN will also have new features. The last one, not really new features, but we did have QA resources and time spent to validate use case, identify bugs, and fix those problems. So let's start with GBP VXLAN. So GBP stands for group-based policy. Right? This feature basically enhances the campus VXLAN VMBT solution or virtual network-based tunneling solution. And 10.8, we basically added this group policy ID portion to the VXLAN header. Okay. It's supported on these 3 platforms, and this will enable role-based policies. That means your policies are no longer tied to IP addresses. So if you have a device that's authenticated, it will have a source-based role, and if that device re-authenticates at a different location or different subnet, that policy will still be applied. So that's the benefit of this new feature. We will be having a dedicated session for more details. This is just an overview, just one slide, give you an idea of GBP. So the next session will cover more details. Stub VTEP also enhances the campus VXLAN VMBT solution. And this is the Stub VTEP here. This will provide VXLAN overlay connectivity between the gateway clients. On the left, we have the gateway clients that could be the wireless or even the wired with UBT that terminate to the gateway with GRE tunnels. On the right-hand side, we have the EVPN VMBT network. We have clients here. So the Stub VTEP will provide connectivity between the static VXLAN network here on the left and the EVPN network. So clients on both networks will be able to communicate this way. So that's the whole purpose of the Stub VTEP. Supported platforms, these are the 3 supported platforms, but because of scale reasons, we really recommend 6400 A360 with VSX for HA here as a stub. You could use a 6300 for demo purposes, but not for production. And again, for Stub VTEP, we have a dedicated session with demos later on. So just an overview here. DHCP relay over VXLAN. Back in 10.7, we added DHCP relay over VXLAN for these 3 platforms. Just to recap, this is what happens. We have clients, we have servers on the same VRF. Client sends out DHCP requests. The first VTEP that receives it will convert that broadcast to unicast, send it towards the DHCP server in the overlay. DHCP server will get it and send a response back into the overlay, back to this client. So he will send an offer from the server through the overlay. So this is intra VRF, where your servers and clients are on the same VRF. So what is new in 10.8? These 2 platforms will also support this feature parity for H25 and 8400. So intra VRF will be supported as well as inter VRF. So your DHCP server and clients can be on different VRFs. That will also work. So if we refer to 10.7 for more details, because nothing new from the CLI perspective or deployment perspective, is just 2 new platforms that are being added. Next, let's move on to V4, V6 ping traceroute over VXLAN. So right now, in 10.8, you can actually ping traceroute between VTEPs, from a VTEP to a host, from a host to a VTEP over both layer 2 VNI and layer 3 VNI. These are the supported platforms, basically all the VXLAN switches support this feature now. And we really recommend a unique IP on your VTEP for your ping traceroute source and destination. Why? So we have a diagram here. For example, this is the default gateway, the .1. It exists on 100 switches, right? So it's Anycast IP. If you try to ping to that destination, what exactly are you trying to reach? Because there are 100 of them. So you should really try to reach a unique IP as your destination in order to ensure that you're actually reaching that destination that you want to reach. So for this feature to work, both the source and destination VTEPs require 10.8. So I have a switch here, 8325 connected to a DHCP server. I have access switches here that connect to a DHCP client. So in this example, it will actually benefit from your trace and ping over VXLAN to verify connectivity. But you can see here, I have a VSX A360. Loop back 2 is Anycast 125.7. That's my DHCP relay source. I also have unique IPs here. Loop back 13, 125.8, 125.9. So those are unique. So you should be using this as your ping and trace route source, right? You should ping from 125.8 to the DHCP server to ensure you get a response back. The DHCP server can reach you. If you use 125.7 as your source, it might respond back to the other switch. So that's why we recommend a unique IP. Let's go to the demo next. So this is my demo environment. I'm going to show you both V4 and V6. I'm going to ping that DHCP server. There's dual stack. So my loop back here is both V4 and V6 address. My DHCP server has also both V4 and V6. Same for the SVI20, which has the default gateway for the DHCP server. Right, let's take a look. Okay, so this is my 6300. First, we're going to look at the routing table to ensure the this DHCP server IP is in the routing table through the overlay. So IP route 2. And we're looking for 20.10. You can see here, 20.10 IP is in the VRF2 routing table. Next hop is the VTEP 11.3. So it knows about it through the overlay. Let's run some pings. Ping, DHCP server, VRF, source. Source will be loopback. So that works. Right? So you verify connectivity through the overlay using your loopback. So let's say your DHCP server doesn't respond. What else can you ping? So you can try to ping something on that subnet to make sure that you can route to that subnet. So we can try to ping to .2, which is the SVI IP. That works as well. So let's say your DHCP server doesn't respond, but this responds. That means it's a problem on that remote host. That's the one way you can isolate if you have connectivity to the subnet. Okay. So that's V4 pings. Let's do a trace route. Next, you can also do a trace from to the DHCP server 20.10 from your loopback. This is the output. You can see here, next hop will be the SVI IP, followed by the remote DHCP server from this 6300. So you can see, right, we could ping and trace route to the host, remote host. Right, this IPv4. Next, let's look at V6. Check the routing table. So we're looking for the FD00 20:10 here. And that's seen in the routing table through the overlay, next hop 11.3 VTEP. Let's verify ping 6 works. Trying to ping to the remote DHCP server through VRF2 using the source loopback. And you can see that also works. That's ping 6. Next, let's move on to traceroute 6. You can see that also works. Trying to trace to that remote DHCP server using your source loopback. Next hop is the SVI IP, and you finally reach the destination. Okay, with that, I'm going to hand over to Justin to cover this radius RadSec over VXLAN.
Thanks, Daryl. Everyone see my screen?
Yes.
Sure. Okay, good. Okay, perfect. So let's talk about Radius and RadSec over VXLAN, which is new in 10.8. So in 10.8, we're providing support for both IPv4 and IPv6 Radius and RadSec connectivity over the overlay in your network. A couple of use cases for that. Why we want to do that is as customers are simplifying a lot of their network using overlays, they might want to extend overlays into their data center to be able to access services for their campus switches. Radius, of course, is a service, so you'd have to be able to access your Radius server that could be in the data center. You know, whether it's ClearPass, ICE, Free Radius. You know, pick your vendor, Radius vendor. So there's a couple reasons why you'd want to do that. One, first use case is to be able to authenticate your clients, authenticate your endpoints at your access layer, and then being able to authenticate via Radius or RadSec, which is secure Radius over an overlay tunnel. Or if you want to have your management users that log into the switch, if you want to authenticate them as well using Radius over the overlay tunnel. So if you're going to authenticate network clients, that's supported on the 6300 and 6400 because those both support port authentication, .1x and MAC authentication. And then management users, we can authenticate whether it be the 63, 6400, 8325, 8360, or 8400. Basically, two requirements: has to support Radius, has to support VXLAN, so that we can bring up the tunnels. So there's really no additional configurations for this feature on CX. It's just something that happens as we have the VXLAN functionality and have the plumbing all piped in between the overlays from the access layer to the data center or core and aggregation layers. It uses the existing configurations for that. There are some steps, of course, that we have to bring up to configure Radius and RadSec to be able to have a secure connection. You know, RadSec being secure Radius is basically Radius using TLS encryptions. So we need to make sure we have the proper certificates installed, which I'll go through in just a second here. But once we get that the certificates installed and the connection established, we are ready to go with authenticating either management or networking users with that. And then we can verify that using existing commands such as the show Radius server detail command. Some of the caveats with this, we need to be aware of the MTU size, both at the interface and at the IP MTU. On all interfaces, if we're using RadSec, since if the certificate is a certain size, we're going to have an overhead with the encryption as the certificate is exchanged between switch and Radius server. So we need to make sure we have the appropriate MTU size configured if possible. If we're using the built-in device identity certificate for the RadSec client certificate, the MTU size should be set above 1550 bytes to make sure that the RadSec connection can come up. So what the configuration looks like, first we have to configure connectivity over the VXLAN tunnel. So we need to make sure we have our BGP configured and that we have the appropriate neighbors and EVPN neighbors set up with BGP. Make sure we have our appropriate VRF configured with BGP, how we're going to advertise out routes. In our case here, we're using a loopback address to advertise out. We need to make sure we have to have our VXLAN interface configured, our VNIs and VLANs mapped out, the source IP defined, which is our loopback on our switch that we're using. And then our loopback address, of course, we have to have that configured for the VRF so that we can be able to test connectivity between our access switch and upstream throughout the network. I think most important is IP source interface command. We need to make sure we have those configured so that the switch can reach out over the appropriate interface to the Radius server, especially if we're using RadSec, to be able to make the connection with the Radius or RadSec server. And then, of course, for the actual Radius configuration itself, we have to define our Radius server. If we're using RadSec, it'll be TLS. For our demo today, I'm using IPv4 for RadSec because my ClearPass does not support IPv6 RadSec. So to test IPv6 with management users, I'll be using a Radius key for that. And then we need to validate connectivity over the VXLAN tunnel. So we can do that by doing a show IP route command specific for the VRF we want to use. And so here I can see my route to my radius server is up, which is at 10.5.8.12. And then I can ping that using my loopback as the source interface over the attached to that VRF. And then I can validate that my connectivity is good to my radius server. Now with RadSec, since we're using TLS, we have to make sure that we have our certificates configured appropriately between our switch and our radius server. So I'm using ClearPass in this instance. And the first thing you need to do is you need to make sure, similar to downloadable user roles, that we have a root certificate installed on our switch that will be signing all the certificates that we're going to be using. So we use a internal Windows server in our lab, which a lot of customers may use if they're doing private. Public, they'd use a publicly trusted certificate authority that they might have sign all their certificates. So once my root certificate is ready to go, I can copy that into my switch using the crypto PKI TA profile command, and I can just copy and paste that into the switch. And then once that's ready to go, we can start creating our leaf certificates. So for our switch, we have to have a leaf certificate for our applications that we're going to be used on the switch to create the trusted certificate infrastructure between that. So I'm creating a certificate here for RadSec. I'm just using the switch serial number as the common name of the switch. And then once I've generated that certificate, I can create a signing request with that using the enroll terminal command. So that gives me a signing request that I need to then go and get signed by my certificate authority. So I copy paste this certificate request, and then I go in and get that signed by my Windows server. And then I can import that back into my switch using the import terminal command, using my trusted anchor profile or my root certificate as my certificate authority. And then once that's been validated and imported successfully, I can then need to attach it to my application and make sure it's set configured to use as for our RadSec client application. And I can validate that using the show crypto PKI certificate command, which then shows that it's been associated as a RadSec client certificate. Once that's done, we can validate that the RadSec connection is up using the show radius server detail command that would show as a TLS connection established. And then at ClearPass, we can see in the event viewer that the TLS connection is up and has been established. So then we know we're ready to go to proceed to authenticating users. Troubleshooting this. So common issues that you're going to see when you're troubleshooting are certificate issues. So you'll see a TLS connection failed in the show radius server detail command. That's going to be your number one indicator that something's wrong, the certificate's not coming up. There's a few debug commands that you can output using debug radius, debug port access, debug PKI. The most common error that you're going to find are SSL errors that I've noticed in issues that I've done in my testing. There's not a whole lot of reasoning, and they're little general errors currently. So you're going to look for is a reason number in the debug messaging. So here I have a SSL connect fail. It doesn't really tell me what it is, but it does give me reason 1048. So then what I can do is we used a fork of OpenSSL on CX, and it's called Boring SSL. And that comes up with a list of the reasons, the error reasons that we'll find. And so you can go to this link here. If I look here I show you here, I've opened it up. We can go down to line 5,338. And that starts our reasons here of what the issue might be. Starting here, we can start with 100. So our reason was 1048. So we can page down here. 1048 is an unknown certificate authority. So I know something's wrong with my certificate authority on my certificate with that. So what my reason was is when I generated my certificate signing request, I didn't have it signed by my certificate authority. So I had to go back, regenerate it, get my certificate authority signed, and then my TLS connection came up appropriately, and I was able to start authenticating users. So that's some of the background information you need to know if you're troubleshooting any kind of errors with RadSec. So I'll show you a couple of use cases here. We have a little setup here that we're using from our Access VTEP. This is actually a Stub VTEP that we're going to be using for GBP and Stub VTEPs on Thursday. But here I'm using my loopback 10, which has an IPv4 address of 10.1, 192.168.10.1. Also the same IP address at 10.1. So I'm going to be demoing how to authenticate a network user or a client using IPv4 and RadSec. And then I'll show logging in via IPv6 and radius over VXLAN for a management user. And my ClearPass is also dual homed at 10.5.8.12 and IPv6 FC00.10.5.8.12 as well. So from here, I've established connectivity over the VXLAN tunnel, and I can then go in and authenticate my users. So first, let's take a look at ClearPass here. So here my TLS connection is up. I'm gonna reinstall or relog in. So my TLS connection has been established in ClearPass. You can see here my TLS client is up. So TLS connection is up in ClearPass, so the tunnel's up. It's coming over the VXLAN tunnel. I have my certificates installed. If we want to look at certificates, we can go into our certificate store. First, I want to go to the trust list. Here is the trusted anchor certificate I'm using, or my root certificate. I have RadSec associated with that this root certificate can be used for the RadSec service. So that's been installed. And then I've gone and I've generated my RadSec server certificate, and I've had that signed by my domain certificate as well. So my certificate's ready to go. We've verified that in the event viewer, seeing that the TLS connection is up. And then if I go to my access tracker, I can see that I have users here that have been authenticated. They're coming in from the loopback address, which from our switch configuration is when I went through the switch configurations are attached to our VRF1, which is attached to the VXLAN tunnel. So I know that my radius requests are coming over the VXLAN tunnel by seeing the input ports from the switch that's been verified. So here I have a user role that's been sent back. This is for GBP on Thursday, but that my user roles and ports have been authenticated. I can also go into my switch. I can see that my clients have been authenticated. I can also validate using show radius server detail, and I can see that my TLS connection is established, as well as I have my IPv6 configured and ready to go as well. So we're seeing that IPv4, we're able to authenticate clients using RadSec. So now let's take a look at IPv6. I have that all set up. And then from here, I can go in and we already have this set. I can go in and SSH from another switch that's has connectivity via IPv6 from this top of rack switch into my access switch. So from here, I can enter in my login information, and then I have access now. So now I can go in and run commands if I need to, show run commands. If we go to ClearPass, I refresh this, we'll see that my username was logged in. I'm using my radius service to log in over management, using management here, and that we're good to go. Coming in over IPv6 from this switch and logging in via the IPv6 interface attached to the loopback on my endpoint, my VXLAN VTEP. So that's how to configure RadSec over VXLAN. And with that, I'll turn it back over to Daryl.
Thanks, Justin. All right, I'll cover IPv4 multicast VXLAN next. So new in 10.8, we now allow VSX VTEPs to function as overlay RPs, rendezvous points, for PIM sparse mode in the overlay. So previous releases, we only supported overlay RP on standalone and VSF switches. So now in 10.8, these are the two new platforms that are supported with VSX and overlay RP. So in this example, I have 3 racks in the data center. Rack 1 is VSX, so that can function as the RP for VRF1 in the overlay for these 2 other racks. So I'm going to use like loopback 3 of this VSX VTEP. This is what the sample config looks like. On the primary VSX switch, in the loopback 3, attached to the overlay, I have IP address 40.111. On the secondary, you notice the same loopback 3 is also attached to the VRF, but it has a unique IP 41.111. It's not any cast IP. They are unique IPs. So that means only one will be have the higher priority. So that is done here under router PIM with the VRF. You specify your priority for both the RP candidate and the BSR candidate. So that means this is preferred by the other switches as the preferred RP and BSR. If this primary switch goes down, the secondary will take over. Okay? So there's nothing new. This is what we supported in the past, right? Even for standalone. But what I'm showing you is a simple config of how it's done on the VSX VTEP. Provide that RP in the overlay for VSX pair. Finally, let's move on to the DCI use case validation. Again, no new features were added to this use case. We just had QA resources and time allocated to validate, to test, to fix bugs. These are the supported platforms that were tested that we recommend. 2 use cases. So use case 1, dedicated layer 2 VTEP. You can see I have a VSX L2 VTEP at the edge of the data center. It could be 2 DCs or 3 DCs or 4 DCs. So these VTEPs will have full mesh peering between them. And this is just pure L2. You typically have a VSX lag connected up to a layer 3 core here that will do the routing between the different subnets. So this pure L2, just bridge VLANs. Okay. So that will function. This could be third party as well, L3 core. So there's no VXLAN required. The VXLAN is only on the VSX VTEP, L2 VTEP here. The next use case is the distributed layer 3 gateway. So we always supported this intra DC. So 2 racks, for example, could run anycast gateways, the same default gateway IP. Right now, QA actually added latency, make sure everything still works in a high latency environment. So, for example, 100 milliseconds, 200 milliseconds, and everything they tested still works. So you can safely recommend that to customers if this is a requirement for them, right? Long distance VXLAN across data centers or sites. So with this, we do not require VRP. We can use up suppression so that if a VM sends an up request for the same something on the same subnet, for example, VM1 22.20 to VM3 22.21, because this information is shared and this VTEP knows about this IP, he will send a response back and prevent that broadcast from going across the WAN. So both layer 2, layer 3 unicast and multicast are supported in this environment. If you needed more racks, this is basically an expansion of use case 2. You can have multiple racks that are fully meshed. All the VTEPs are fully meshed here. So there's one VXLAN fabric across the different sites. So with this, there are scale limitations, right? But just be aware, it's just like one VXLAN fabric within one site, just that we're spreading the VTEPs across multiple sites. And both layer 2, layer 3 unicast and multicast are supported as well in this environment. So we will be enhancing it further in 10.9 to overcome this scale limitation. Right. Thank you.